Hi everyone, this is Mrs. Gonzalez Clark again. Today we are going to continue our work with volume. The last example that we worked on, we looked at a three-dimensional figure and we talked about how a three-dimensional figure has a length, it has a width, and it has a height. And what we did with this three-dimensional figure is we figured out what was the length, the width, and the height of each of these layers, and then we took the amounts of each of these layers and we added them together, which gave us the total volume of this figure. Now, just as a reminder, the volume of this figure was 24 cubic inches. So what we are going to do today is we are going to use the same amount of unit cubes. We are going to deconstruct this figure and we're going to see if we can make other three-dimensional figures using the same amount of unit cubes, thus having the same volume in each figure as this one. So we're going to create more figures using this same amount of unit cubes, and we're going to see how building it differently can still give us 24 cubic inches. So this was our initial figure here. With the initial figure, we had a length of 3. As you can see, the 3 different unit cubes going across. Our width was 1, 2, going back. And then our height was 1, 2, 3, 4. And then we took all of those amounts and we multiplied them, which gave us the 24 cubic units. Cubic inches, pardon me. So now what we're going to do is we are going to dismantle this. And we're going to create a new three-dimensional figure using the 24 cubic inch unit cubes, and then we are going to see how much is going to be in each layer of our new figure. So I'm going to think, what numbers are divisible by 24? So what number can I think of that 24 can be broken into equally? So how about 12? So I'm going to create a figure where my first layer is going to have 12 cubic units. Pardon me for my slow construction. Okay, so here we have one layer of 12. Okay, so our length is 1, 2, 3, 4, 5, 6. Our width is 1, 2, and our height at this point is just 1. So that means we are multiplying 6 times 2 times 1, which gives us 12. Now, our figure needs to have 24 unit cubes. So I'm going to, since I have 12 here, I know if I put another 12 on top of it, that's going to give me 24. So let me create that. Okay, so here is another layer of 12. So we are going to see how many cubes are in each layer. So we already determined that based off of the first layer, our length was 6, our width was 2, and our height was 1, which gave us 12 cubes in one layer. So I'm going to put that here. Okay. Now we're going to see how many layers we have. Well, we have one layer here, and we have another layer here. So that means we have 2 layers. Okay? And now we are going to find the volume. So if we have 12 in one layer and there's 2 layers, all we have to do is 12 times 2, which is equal to 24. So therefore, our volume is 24 cubic inches. Pardon me, I'm having a little technical difficulties here. Okay, so we took the 24 cubic inches that we used from the last volume, from the initial volume that we used, and we created a new figure, a rectangular prism, a 3-dimensional figure that still gave us a cubic inch volume of 24. So now we're going to do the same thing, but we are going to create a new figure. Again, still using the 24 unit cubes, we are going to create a new figure which will have the same volume. So I'm going to think again. How can I create a 3-dimensional figure that's going to give me a volume of 24 cubic inches, but I need to be able to have layers within this figure that have the same amount of unit cubes in it. So for the last one, I thought about, what numbers are divisible by 24? So I thought, 12 is definitely a number that can be made out of 24. I can make groups of 12 out of 24. Now, what other number can I use that I can make groups of out of the 24, equal groups out of 24? So how about the number 8? So I'm going to create my first layer using 8 unit cubes. Okay, so here I have a layer of 8 unit cubes. Now, my volume has to be 24 cubic inches. So I need to make sure I have to determine how many layers more am I going to need in order to get the volume of 24 cubic inches. So I know that 8 times 3 gives me 24. Therefore, I know that I'm going to have to put 2 more layers on top of this layer in order to get a full volume of 24 cubic inches. So let me just go back to my chart, and I'm going to put that the amount of cubes in this layer is 8, okay? Now, I'm going to put the new layers on top so that I can get that full volume of 24 cubic inches. Okay, so if I have 2 layers, so 8 plus 8 is 16. And now as soon as I put my next layer, I'll have 3, which would give me 24. Okay, all right. So how many layers do we have? We have 1, 2, 3 layers. And now we can find the length, the width, and the height of this, or we can just know that in each layer we have 8 unit cubes, and since we have 3 of those layers, we can do 8 times 3, which gives us the 24, or we can use the volume formula to figure out the volume as well. So our length is 1, 2, 3, 4. Our width is 2. And our height is 1, 2, 3. And again, 4 times 2 is 8. 8 times 3 is 24. So again, we get the same volume as we did with the previous figure we just made and the initial figure that we made in the last example that we did the other day. And there we have it. Now, I'm not saying that there aren't any more figures that can be created, but the point is that we were able to use a 3-dimensional figure the other day that the volume was equal to 24 cubic inches. And we were able to construct new 3-dimensional figures that still had the same amount of unit cubes and still equal to the same volume as the initial problem that we did. Like I said again, we can make more, but I just wanted to show you how you can take one figure, change it, and still have the same volume.